Behind every great product is a great seal. Join us at the crossroads of preeminent product design engineering, seal mastery, and supply chain excellence, and learn from the makers of our future.
Hey, welcome again to Makers of Our Future, for conversations with the people behind the products that are changing the world and for people in the seal industry who are making that success possible. I'm very excited today to introduce you to Steve Barton. Let me introduce myself first. I'm Bill Sharrett, Vice President of Business Development at Darcoid, and I am your co-host for today. Darcoid put this podcast together just to create a searchable store of wisdom for people who are getting to grips with seals for the first time. Steve Barton, my guest, has been in the seal industry for more years than he will probably care to mention. He, over his career, has developed considerable experience in engineered materials before moving into rubber, into the world of elastomers. So I could say a lot about Steve, but I think we'll get to know more about him as the conversation develops. So Steve, welcome to Makers of Our Future.
Thank you. Glad to be here.
Thank you. I'm glad to have you with us. You've been in business development at Darcoid for a long time, certainly preceded my arrival at the company. You've, like I said, developed considerable experience in this field. What got you into the wonderful world of rubber? I like asking this question of people because there's a wide variety of pathways into this career. So how do you find yourself here, Steve?
Well, I originally started out in aerospace, and towards the end of my aerospace career, I was working with a project that was rubber for the Titan IV missile. And as that industry kind of does something.
Come on, okay, all right. Am I talking to a rocket engineer here? What's the deal when you Titan and aerospace? How involved were you with that?
I was a design engineer for the Titan missile, for the ordnance and the hardware up in the top.
The stuff that goes bang at the sharp end?
The brain.
Okay. Excellent.
And the raceway, which is what carries the cables from top to bottom and controls the bottom, which is the outskirt. I was involved with that a little bit and got involved with the rubber. So we were putting a rubber coat, or if you will, over the outside so that it wouldn't burn up as it was going up into space. When the aerospace industry kind of took a hit because our Titan missile blew up on a test stand down in Edwards Air Force Base, and they had to start reevaluating how they were going to move forward, and they laid off about a third of their engineers. At that point,
I'm sorry. I'm back to the sharp end of rockets, Steve. it was the Titan, the one that's submarine launched, or is it like land launched from silos? I'm just trying to place that in the.
It is the space shuttle is 12-foot diameter, and this Titan is a 10-foot diameter.
Oh, okay.
On the fluid side, so you have the rocket boosters on the sides with the main core in the center, and it's a payload. So it was a payload rocket that would take up 25,000-pound envelope of satellites for the Air Force.
Fantastic! Wow.
So
okay, it's interesting. You know, I think you're the third person I've spoken to who just happened to mention that they design rockets or some component of rockets. So people are always so humble about it. It's interesting. So was that a seal, or was that a kind of cover protective? Was that your first experience with seal at that point?
It was my first experience with rubber. It was a silicone cover that was kind of like a three-sided square, so it would go over the top, and then we would glue it to the actual side of the rocket. It was just a protective skin so that it wouldn't burn up as it was going into space.
Cool.
When we were all given a lifestyle change, I contacted the company who was making those parts down in Southern California and asked them if they had any openings, because I was kind of intrigued with rubber at that point, and they did. They said, we do have one up in Modesto, California. So I took that position and came down to Modesto to start learning about rubber.
Okay. And is that in a manufacturing environment?
And it's a rubber manufacturing facility that builds a variety of rubber. Not many of those were O-rings. Most of them were custom seals.
Okay. Injection molding, compression, transfer.
They're mostly compression and transfer.
All right, Steve, teach us something. Teach us something.
Not quite as valuable back then.
Okay. Teach us something about molding. What is compression molding?
So compression molding basically is where you have the plates of the seal. The tool will open up. You might have a center plate, but then you put what we call a preform, which is raw rubber, and you stick that inside and put it by the cavities. Then you compress that, and typically we call it burping. That's the old version. You would open and close it very quickly to let, as the rubber starts to move and get hot, it tends to start to flow, and you don't want to trap air, so you burp it. That was the old versions way back when. And then as it closes and it heats up to a 350 degrees, then you begin the cycle of 6-7 minutes and it cures.
So the analogy would be like a panini press, compressing the sandwich and heating it.
Right. You're making a grilled cheese sandwich.
There you go.
Or a
that
waffle.
Kind of panini.
Or a waffle.
Okay.
A transfer is at the top. It's got another plate with a little pot down inside, and you drop the rubber up in that top pot, and it's got a bunch of sprues or little holes that will then take that hot rubber and run it down into different cavities. We call those sprues. So as that starts to heat up, then the rubber gets hot, starts to go down and drops down inside of all the cavities. The disadvantage of that, I mean, there's a lot of advantages, mostly for low run situations, but the disadvantage is that you have a heavy amount of waste because you throw that
sprue
channeling and everything away every time you run a cycle.
So can you get a more complex shape out of a transfer process, or is it really more for small run bespoke kind of production?
It's hard to get a real complicated part of that, only because with sprues going on, you tend to trap a lot of air in complicated parts. So you need a bigger tool with bigger tonnage, and transfer parts don't usually run that well on large tools with a lot of complicated cavities. What we ran that for was when we would what we call nest or family. We'd have 4 or 5 parts that were all the same compound, but they were different sizes, and they would nest inside of each other. And when it would come down, it would just go across, and then you just cut that little flash off the side, and you can plug it, so you only make 3 out of the 5, or you can make all 5, or maybe you just only want to make 1. But that way, it's a little more flexible for small runs on things that you do.
So, I be careful not to go down a rabbit hole, but if you're moving rubber at temperature towards its final cavity destination, do you risk it actually starting to cure and set as it moves towards its target? I mean, that sounds like there's a lot of controls that you need to be concerned about.
Well, you have to understand the rubber that you're using, how flexible it is, and being able to move. We would never do a fluorocarbon in a transfer hot situation because it doesn't move at all. It's very slow moving, and you wouldn't be able to get it to go down and run through those sprues. That's primarily, it's best for silicones and nitrile. Maybe nitrile even tends to be a little bit of a problem. But yeah, it'll cure up fast. So you have to kind of understand what you're working with and how far it has to travel, and then the temperature that you're going to be curing at, because you only have a small window to get that going, and then it starts to cure up.
At Darcoid, we like to say we got a real good knowledge of all the steps of the manufacturing process, so we know where to look in case we get a quality issue or an efficiency issue from tooling. that clearly is an area of focus. So you're in Modesto. Were you operating presses? Were you designing tooling? What was your how close to the rubber were you getting there?
As the engineer or as the salespeople would bring in new projects, the one thing I learned right away is that a lot of times sales guys don't understand. They just sell. Hey, I'm going to sell it. We're going to build a tool. Hey, look, we did it. They have no idea a lot of times if it's doable. And so I would help build the tool, and then when the tool would come into the plant, I would be the engineer who would actually set it up and run trials, and then come up with the final version of how the guy on the floor could run it. So we'd figure out how to make it work. And once we got it to work, we'd do our instruction sheets, put that all together, and then the goal was that we would run the part so that anybody off the street who knew nothing about what we were doing could read that instruction sheet and be able to make it work.
Repeat manufacturability and okay.
And sometimes it would take 2 or 3 days to get it to where it needed to be before we get it to run, and other times you run it twice and it's good to go. But that's what I did. Is I was the development engineer, so I had to make sure that those parts would work and they would run on the floor, and then we turned over to manufacturing and let them run production.
So some of the sales guys coming in with projects like cats bringing in a dead bird in the morning, some would suck up to you because they know you'd be the one to make it happen, and others, I guess, would be like, "Oh God, I've got to talk to Steve now. He's going to tell me why we can't do this." Right?
Most of them didn't care. No, I sold it and I'll make it work, and that typically was how it worked. But it was interesting. We did a lot of different things, from naval into food industries, and each one of those had very complicated things that required a lot of trials. I mean, we bloodied our nose a lot on some of these projects. There are a few projects that took us almost two months before we could figure out how to make it run.
I think that's an important thing as a takeaway. It's you can draw up a shape in solid model or sketch it out and assume it's a no-brainer, but there's a lot of detail and a lot of expertise to create that component with the workmanship that you need, with no air pockets and non-fields and voids and excess flash, right? So a lot of expertise behind the curtain. Yeah. True.
And I think that was, for me, that was a big moment of understanding. It was such a challenge of learning all the different things. At first, I just thought, well, it's just rubber, it's just a seal. How complicated is it going to be? And I'm going to get bored, I'm sure, and want to go do something else. And then I realized almost immediately, if you learn the details, you can go deep into each one of those little rabbit holes, as you call it, learning all the details. And a lot of times, many people overlook that. And then when it comes time to make the part, there's a lot of things that they have not took into account, which then we now have to take all that into consideration as we help them build the part. But that was something that I started to learn. I got very interested in the fact that there's so many different types of materials, different families, and they all run differently. And so you learn how to make sure that each one of those works. And now I draw on that experience a lot. In fact, I think that's the thing that has helped me become a good sales engineer, is that I understand the sale. I understand the engineering part of that. I understand how it works. And I rely on the chemist in our company, None, who then can help me with the chemistry side. And then between those two areas, we're very valuable to help solve problems.
Had an interesting chat with Nand on this podcast a few weeks back on risk management and risk mitigation. And yes, clearly we scratched the surface of quite a rich area of expertise. Let's stick a pin in it. I've got something to talk about in a minute, but regarding rubber. So what got you out of the factory into the field, or did you go into another area of engineered materials. What was the next step for you, Steve?
Well, after I had been running rubber for a while, I started to get exposed to polyurethanes and hand molding in urethanes. You know, skate wheels, those types of things is what I started to get involved with. Then we started
skateboard wheels. Okay.
Yeah, skateboard wheels and inline skating. And then Motorola came to us and asked us if we would make these little holders that would cut their chips for their phones. And so we got involved in doing that, and that became very, very complicated for me. It took a lot of time for us to figure all that out. But then I started falling in love with urethanes. While I was still doing rubber, I started to fall in love with the urethanes, and then.
Was it a chemical addiction? Was it because you stood too close to the raw ingredients or something, Steve? What was going on?
I think it was just because it was a new challenge,
and
I didn't understand it. And because I had been exposed and I didn't understand it, I felt a need to conquer it, I guess. I wanted to understand.
Well, what's different? What's different with a urethane than a regular elastomer? Isn't it just another elastomer?
Well, it is, but they run. They're very fluid, obviously. So you've got to run them hot.
Oh, is this a cast urethane? Is this like liquid poured into a cavity kind of a thing?
Yes.
Okay.
And so we got an injection machine for that, and that basically doesn't really inject. What it does is that you have 3 ports where you have your chemicals all lined up, and it will heat up and suck all those up into the machine, mixes them up, and then it pours into our containers, or it pours into the cavities as it goes along.
Okay.
I had never really done that before, and then we started to get into rubber rollers for the paper industry, the rollers that handle the conveyor belts, which was a different type, 50 durometer, Shore A, all the way down to where we'd run these elastomers, these other parts, which would be Shore D. So they were very, very hard. It was just a different experience with polymers, a different type that I had never done before. So I got involved with that. And then the boss came to me and said, I want to put you in charge of that department. And I laughed at the time because I said, I don't even know if I know how to spell urethane. and you're going to make me a part of that. But I was happy because then that kind of helped my experience open up a little bit more in just one more area that I didn't understand. And I think that's when the point came along where I thought, maybe I need to jump into foam and then into plastics, and then I'll have a very good, well-rounded area of understanding most of those types of applications. I got into being a salesman because I kept getting calls at 2 a.m. from the factory, sometimes even 9 or 10 times during the night, saying, hey, it's not working, can you help me fix it? And I'd talk it over the phone with them, and then sometimes I'd have to drive to the factory and help fix the problem.
So they got a little old, a little fast, I'm sure.
I finally decided, I want a regular life where I don't have to work all day and then work all night. And so I thought, well, I'll just go be a salesman because that seems pretty cushy.
Right.
I didn't understand what all that meant, but I think the experiences of me working in the factory for so long has brought a knowledge base that I didn't think I was going to have. And now as a salesman and a sales engineer, I draw on that experience daily. And I think that's given me an advantage over a lot of other people who maybe learn it from a book versus learning it from being on the floor and having to figure it out. And I think that gives me my troubleshooting capabilities of being able to analyze and figure out what the problems are, because I did that for a living for 10 years.
It reminded me, book learning. I forgot where did you get your educational start? You are a mechanical engineer by training, yes?
I'm a manufacturing engineer. I got my Bachelor of Science degree from Brigham Young University. Okay,
excellent. So BYU, I'm assuming they did not teach you much about molding rubber, urethanes, foams?
No, but my plastics teacher that I had was a retired chemist for DuPont.
Mm.
Taught our plastics class. So that kind of also piqued my interest. But, when you graduate from college, you take whatever you can get originally, right? You take whatever job you can find.
Yep.
And so eventually when I went back to plastics and I got more involved in that, a lot of those memories came back. And then I started to realize that I had a fond love of rubber, plastics, urethane. And I guess it was just waiting for me to find it so that I could explore it and understand. But I've been doing it for more than 30 years.
Fantastic. You can't help but learn, can you, over that time frame? You've got rubber, urethanes, foams, then plastics. I mean, are we talking engineered plastics or because I know plastics are used as seal components. They're often right next to a seal in application. What about plastics has stood you in good stead through your career?
I will admit my experience with plastics is a lot more limited than it was with urethane and rubber and foam. We did a lot
enough to be dangerous. Knew enough to be dangerous?
We knew enough to be dangerous. We did a lot of manufacturing for the golf industry. We would make these discs that would go side by side and be dragged behind a trailer that would pick up golf balls at the driving range.
Oh, yeah. That moving target that you see at the driving range.
Right. Okay. We made millions of those plates that were used for the driving industry. And then with our urethane, one day we realized that as the material gets a heat history in these 55-gallon drums, it becomes useless. You can't use it anymore. And so we were throwing some of that away. And one day we had a guy come in and say, "Hey, is there any way you can make me the driving range mats so that I can put those in the driving ranges?" And that's when we realized that urethane can be used as a binder, and all the rubber that we throw away can be ground up, and we call it chrome rubber. And we mix those two together in a cement mixer with heaters on it and pour it in, and then we compress that, put the green grass on top, and those are in probably most of the driving ranges throughout California.
Wow. You and Nand Patel, both early pioneers in recycling earlier in your career. I love these conversations. I'm learning so much, Steve, from the sharp, noisy end of rockets to pioneers in recycling. That's fantastic. Well done.
It was just a way to, because we would throw away a full container, a full dumpster of rubber every week. And when we figured out we could send that out and get ground and bring it back at maybe 10 or 15 cents on the dollar, and then use all that urethane, which we typically, we started to decant. They call it decant. You measure, you heat up the drum, and then you pour it into 5-gallon containers. And so it only takes one heat set. Then you can use those a little more often. But when you're running it out of a 55-gallon drum and you have to heat them up 3 or 4 times, it gets to a heat history where the binder doesn't work as well as it used to. And technically, you're not supposed to use it. But it would work great as this binder. And so we ended up to save quite a bit of money for that, and also serve an industry that we had no idea would be, doable.
Nice. Excellent. So when did you make the break into business development, armed with your wealth of knowledge on real world, how it gets done, information?
When I broke into sales with a company in California, after I'd done that for a couple of years, I realized there was one area that I was really short in, and that was understanding the supply chain side. So I went out and became a consultant, and I started my own business as a consultant so that I could learn about suppliers overseas and all over the world. And basically what I started to do is I would get product built at these places, and then I would sell them to customers. I was the middleman. It was just me. So I couldn't do, intense government work or complicated things, but I did have several government customers that I worked with. They would come to me because I could do one-offs for them versus the big customers. And I learned a lot about I can't make this anywhere but in the US, or I can make this overseas.
Mm-hmm.
And today I still have a lot of contacts that I use now that I met and learned way back in the early 1990s as a engineer that went out on my own to find more supply chain base who could help me do what I'm trying to do. And we actually use some of those now in our company now.
Fantastic. All right, then, in our company now, fast forward to Darcoid, business development with a single focus on seal applications. How did you make the jump from knowing how to mold a quality rubber component to engineered seals and functionality of seals? Where did you pick up that experience?
Well, as I became a salesman, especially with Darcoid, as I came on, I realized that I was tending to pull myself towards the engineering side because that's what I did. And then I realized I have there's a real niche there that the engineers need to be able to help them at the beginning of taking their seal, making sure that it fits in their application, that it fits in their housing, that it serves the purpose they're trying to do. I also learned that many times a lot of engineers have the same feeling I had way back when, where it's just a dumb seal. So I'll get all the big details out of the way, and then I'll worry about the seal last.
Mm-hmm.
What that tends to do, though, is you leak. You have problems. Your envelope is smaller than it needs to be, or you have the wrong compound chosen, and then it's
too bloody late.
It's too late to make a change because you waited till the last minute. And that's not necessarily, I understand their concerns. I understand why they take that as the last option, because sometimes they just think it's just a silly little seal. But after they have a leak or a recall, suddenly that seal is the most important thing in their whole application.
Sure.
And I try to explain that to them up front. Sometimes they get it, sometimes they don't. But I guarantee you, once they have that experience where it fails for them, they never take it lightly after that. And I try to avoid having them learn that lesson, so that they don't.
Yeah, the assumption is it's a no-brainer. The assumption is it's not going to be a problem. But when it does blow up in your face and derail your product launch or whatever, that is a hard-learned lesson that stays with design engineers for a long time. I'm going to, back to my note here, segue into to rubber and performance in application. When I was talking to Darren Peddle, Darren, a very well-experienced seal designer, he kind of said rubber just doesn't behave like any other engineered material you've ever worked with. Do those words ring true to you, Steve, in terms of seal applications and what it actually does in application as opposed to what you assumed it would do?
Absolutely. I think a lot of times we get used to we have a certain picture in our mind of what rubber does and what it is. And I think that's a dangerous way to look at things, because you can have a certain rubber and a certain type of family, and it may behave differently in each different application you use, and use the same compound in all 5 different applications, and it behaves differently in all 5. There's a lot of components that add to that: temperatures, pressures, fluids, or whatever it's going to be exposed to. That's what changes the way the rubber behaves. And so you need to kind of understand that. Otherwise, it can be very frustrating. Your learning curve is steep for quite a while. I think for me, that's one of the things that I've enjoyed, that I've realized that if I can bring that expertise I've had for all these years and draw on that, that's what makes it valuable for the engineer. I've learned over the years that if you come into an engineering group and you are not prepared, engineers typically don't want to listen to somebody who doesn't know what they're doing.
Sure.
They don't have time, and they will judge you almost immediately. So sometimes the young sales guys, like I was, if I had not had all that experience before on the floor, I would have been one of those guys that the door would have been shut on me and I would not have been able to get back to some of these locations. But being able to look at what they're doing and give them a solution almost immediately, they saw that as a way to cut down on some of their time. This guy knows what he's talking about. Let's rely on him so I don't have to do it all myself. And that's the thing that's been valuable for me, and being able to help these engineers solve their problems. Now, you always will get people who they'll push back and resist, and you do all you can. And sometimes it works and sometimes it doesn't.
Sure. I was reflecting. It's you're the rare package, Steve, of someone who has a wealth of experience and can talk technical, hitting the ground in just about any conversation about a seal application. But it's got to be pretty darn intimidating to newcomers trying to step into that role, especially when you get a meeting with someone technical. They will sniff you out in a minute or two on whether you have the chops to support them, which is intimidating. So again, why we're building this podcast, we're trying to create store of knowledge and wisdom, but also why plan B, if you're that new salesperson, work for a company that's got a really solid technical support team that's ready to jump in and engage on that conversation with your customers. So that's a big push that we've been making, building out that technical resource. So it's a balancing act. You've got to be the guy who knows enough to be dangerous, but if you don't know the answer, you've got to have a team that can jump on that call straight away and engage. Correct?
Right. I mean, there's techniques that I've built over the years that you're not going to know everything in the conversation when you have it. The trick is to not let them know you don't know it. So a lot of times when I've come up against something very complicated, I have just said, I appreciate all the information you've given to me. Please forward me all that. Give me a few minutes to just kind of review it all. I'll get back with you tomorrow. You get off the call and you go, oh my gosh, I don't know what I'm doing. But they don't know that. And so then it gives you some time.
Well, they do now, Steve, because you're now on the internet saying that's your trick.
I don't have that problem anymore. But that was, I learned when I was in aerospace, I had to make a presentation and we flew to Denver and I thought it was just some engineers I was going to be talking to. I'd been out of college for 2 years and I was in the project office, so I was by far and away the youngest person in that group. And I had a 5-minute presentation I had to do. And as I got into the room, I realized they were the Air Force generals, all the brass from Martin Marietta and the Air Force were in that room. I was going to present to them.
Nightmare.
and I remember one of the bosses from the other company, the main parent company, came up to me before and he goes, listen, you can only do what you can do. So only talk about what you know. If you try to say things that you don't know, people will know that immediately and you will lose all credibility in that conversation. And that has stuck with me my whole career of talk about what you know. If you don't know it, don't talk about it because people will know immediately that you don't know what you're talking about. And I think that's also how you gain credibility as a sales engineer is talk about your strength. And if you don't know it, then you realize, hey, that's an area I need to learn. And you go and you do your homework and you do your studying and you get good at it. But don't talk about stuff you don't know because people will know that immediately and you'll get that reputation.
Doesn't matter whether it's seals or whether you're discussing the next great golf ball design, whatever it is. I think that that holds true. It's personal integrity. But before you go in the room, make sure that you have the resources to discover any information you need at your fingertips. Static seals, dynamic seals can be different beasts in terms of how they perform, considerations. I know you have considerable experience in both. Any top tips for an engineer looking at one type of seal versus another?
Well, yeah, I mean, it's quite different between the two, static versus a dynamic seal. I think most of the cases, if it's just rubber, those tend to be more static than they are dynamic. Dynamic typically has to have some reinforcement. It's going to have plastic or metal on there to help it be stronger. I think the thing that I've learned over the years in static applications is I kind of call it a static dynamic seal, because in some of the things that we do that go on these big trucks, even though it's a static application, when that engine is bouncing around and that whole housing is bouncing all over the place, that seal is taking a lot of beating that you wouldn't normally see in just a simple compressed gland. And so it tends to take a little bit more of a dynamic approach. And we saw a lot of failures from that. We realized, okay, we've got to get a different material to accommodate the shake and the vibration versus just the heat or the fluid or the temperature or the pressures. When it comes to dynamic seals that have plastic or metal backings, then you have a whole different area of what you work with. Now you have built up heat, you have friction, torque, a lot of those things that you didn't see before in a static application, you see in dynamic. So I think learning the basics, I think, is the most important thing. I mean, I've seen a lot of guys who don't understand the difference between the two very well. And like anything else in rubber, every day is a new experience, but those two areas are vastly different from each other as far as the application and more importantly, how they're made.
Yeah. I'm going to try and lead you along a certain path here. Bear with me. So it's about understanding the application, the actual end use. Oftentimes when we're onboarding a new project, we are given an information set and have at it. That's all you need to design the seal. Right. Sometimes there's some frustration because we come back and ask more questions, and sometimes even more questions. How much do you need to know about an application to really start working up a really good design?
Well, I think obviously it helps to understand the application, but perhaps the most important thing is I try to arm myself with a few questions that apply in almost every situation. And so if you can ask those 3 or 4 questions right up front, that gives you quite a bit of information on at least how the seal is going to be working. The environment the seal is in is the first step. I mean, you can understand the entire application. Yeah, it goes in an engine, but if it's right on that one corner that never sees the fluid or never sees this, and it's just a little seal to help prevent getting dirt and everything else in there, it doesn't really matter what the engine is. It's the environment around that particular seal is the most important question at least to start out with. So I always ask, what are the temperatures it sees? What are the pressures it sees? And what's the environment it's in? Meaning, is it air? Is it fluid? Diesels? Is it gasoline?
Yeah.
That's how I start normally. And then that'll give me the basis of, now I can choose a compound based on the temperature. I can choose a compound based on the fluid application. Yep. And then you can go from there.
Yeah. Good. And keep validating. Oftentimes, customers aren't quite sure of some of those key questions, like as you alluded to earlier, the harmonic effect that some static seals can be exposed to that makes a difference. Got any examples of situations where you've been in a seals taken for granted and something didn't work out late stage, or a change in associated hardware tolerancing might have thrown something? Some examples, or an example of how you rode in your white horse and came to rescue.
Well, we've had several. One that comes to mind is we had a seal that was in a gland the gland was made up of 3 mating surfaces. So 3 mating components came together to make the gland for the seal.
That's a tricky one from the start, right? Having yes, okay.
And it was plastics, and it was casting metal.
Hmm.
What happened was over time, the plastic started to go one way because as it wears out, the gland gets bigger and the casting was starting to wear out a little bit on the tool. These are the tools. So as they were making these parts, it started to change the dynamics of the gland.
So they're into their thousands or millions kind of
right.
in
so
production.
As they're getting bigger, they start to change. The odd thing is one changes to a tighter fit and the other one's changing to a bigger fit. So the gland started to shift a little bit and the rubber just couldn't handle that big of a transition. And they caught it after they had made almost $1 million worth of hardware. Well,
like WIP, work in progress hardware that now couldn't be used.
Now done and ready to be assembled for final assembly. And they couldn't use it. So we knew that the seal was going to be the easiest thing to change because that was, at least in this case, the least expensive of the two. When you have a $200,000 plastics tool and $150,000 castings tool, my $5,000 rubber tool was probably the easier of the two to fix.
Path of least resistance.
The problem was we were trying to figure out a way to be able to still use all those parts. And so we started to do spreadsheets with Excel to figure out different compression sets because you're going to have min, max, tolerance, stack ups, all that good stuff. Ultimately, I had to make a choice of what are the chances that I'm going to be on this end versus on this end of the tolerance stack up. Where is the worst case scenario that I'll see? And then I asked for all the data and they sent me probably 400 inspection sheets of each one of those parts. And we put that on our data sheet and we went through and figured out there was a window that covered probably 85% of all the parts that had shifted over. So we made our O-ring for that and then just took a bet that the others probably weren't going to be affected.
Extreme.
Right. And we ran those and then we came up with a seal. It was a custom seal, custom O-ring, and we gave it to the customer. They ran through it. We gave them a bunch of samples. They ran it. It worked. And then they came back and said, will we be able to use this on all the existing hardware? And I said, that's the way we developed it. And then they changed their tooling to meet that new, more robust O-ring design that we had for the long term. But we were able to save about $900,000 out of the $1.2 million worth of scrap.
Fantastic.
So that took a long time and there was a lot of pressure on it. It wasn't necessarily because it wasn't our fault. So our seal was performing the way it was designed, but the pressure was, people's jobs and livelihoods.
Yeah.
Making sure that we didn't get anybody fired and being able to keep everybody employed and also come up with a way. We ran about 150 iterations on the spreadsheet and came up with one that worked. And it took about 2 months and we finally got it to work. And it ran for about 3 more years and then the program ended. It was the life of the program and it ended. But
$1 million and jobs on the line.
I went back to that facility about 5 years later and the general manager, that was one of the first things he said was, I remember you. You're the one that, and he brought that whole scenario up and well, I'm just glad I could help. But for me, it was very exciting because it was something I'd never been able to do before. And I was lucky enough that it worked.
Well, lucky, but it wasn't throwing darts, was it? I mean, you crunched the numbers. You really looked at the data spread and the statistics, and so solid work, solid pursuit of data, and solid grounding on how seals work and what you need to do to optimize them. So, win-win-win. Well done. Good. So. As we wrap this, because I know I want to respect everyone's time, do you have a list or a sense of the most common mistakes or oversights that are made when someone's designing a seal? Certainly when you get the call that something didn't work as expected. What What are the most common drivers behind those dramas?
When I first start working with engineers, the most common thing that they do is they misjudge the gland fill, meaning the seal goes in there for compression set and for volume fill. They misjudge that based on the pressures and everything else that are going to happen. And so it tends to be they under design. And so it's too small. So they don't get a good compression set in there to keep it from leaking. As I get going with them, they start to learn that. The older engineers tend to make mistakes with the compound choice.
So they got the mechanics down. They got the basics of gland fill and squeeze and so on.
Right.
And that's okay.
It's an interesting phenomena that I see a lot of times. Engineers will take a previous program. Hey, that worked great on that program. Let's put it on this one. And they take the exact same seal and they put it on that one. And the size is the same, but the whole application is completely different. And then what leaks, they're frustrated because, well, it worked over there. Why does it not work here? Well, that ran at this temperature. This one's running at this temperature. That ran in diesel. This is running in biodiesel. They're not the same. And there are compounds in biodiesels that will only go, 9, 10 months, and then they die a horrible death. And then there's life of the program parts where you need to make sure that seal will run for the next 7 or 8 years in that application. So that, as we get along farther, they tend to misjudge the compound with the application, the materials, versus the younger guys just goof up the simplest of things, which is the compression sets and that type of thing.
Good. Mentors. Who's influenced your career? I think you touched on this earlier. What word of wisdom has stood you in good stead? I think we touched on know what you know of which you were talking about. Anything else that has really been impactful in your career?
Well, there was a man that was a good friend of my father. When my father passed away, he kind of took me under his wing to be a mentor. I didn't look at him as a mentor as much as he was just a really good friend. And one of the things he told me was, he said, whatever you do in life, he was a very successful businessman, but he said, whatever you do in life, make sure that when you go into that new job or whatever it is, the biggest mistake people do is they go in there and then they start talking to everybody and they're not prepared. They don't know what they're doing. And he goes, if you're going to go into any application, especially if you're an engineer and you're going to be a sales engineer, when you walk into a room, be prepared. Do your homework. Know what you're talking about. Get yourself ready. So when you walk in there, they know you know what you're talking about, because he said, just like any business deal, you get one chance. And if you blow that chance, you will most likely not get it again. and sometimes the big deals only come once or twice. So if you goof up both of those, then you're not gonna be a good engineer and you won't survive. And I know he was talking more about, he did the big dollar deals and all those things, but it kind of rang true to me. And as I started to go through all these different organizations to be an engineer, learning how to do urethanes, rubber, foam, that kind of started to ring true to me of when I go in there now, I have a lot of experience on how these parts run on the floor. I need to figure out how to apply that in my current job so that I can be that guy who walks in and doesn't have to worry about it. A young engineer that went with me to one of our customers, and they hit us up with a lot of projects, a lot of problems. And when we got all done, the guy came to me and he said, how do you do that? You were shooting from the hip the whole day. You never opened up a book. You never looked at anything. You literally were shooting from the hip and you had answers for everything. And I thought, well, that doesn't happen overnight. That was a lot of experience for me working on the floor. When I see a problem, I record it. I see another problem, I record it. And then I remember, oh, it worked in this application. this is a very similar way of doing it, and that's how I apply it. And I told him that too. I said, that's something you have to learn. Sometimes as an engineer out of college, you're book smart, but your experience is very, very low.
Pay attention. Build on what the experience that you've lived through before. Don't show up stupid.
Well, I'm not trying to say it quite that way, but if you go in there and not really know what's going on, at least don't act like you know what's going on.
Yes. Yeah. Excellent. All right. Steve, anything that you'd like to cover that we haven't whilst you have the opportunity?
No, I appreciate the opportunity. I think the world of rubber is changing every day. And I guess the advice I might give for some of the younger guys is you're never too old to learn. If you get to a certain point and then you become comfortable, I use it to the liking of my grandma had a telephone that was a dial. And until the day she died, she only used that dial phone. Well, if you use that in your world today of technology as an engineer, and you're still using a flip phone or a dial phone, you're so antiquated that nobody wants to go to you because you were living in the 70s.
Mm.
You've got to learn every day to keep up with everything so that you can be influential.
That ties really well with Craig Rossley's advice on an earlier show. He was in an entirely different field, but basically saying if you're not uncomfortable, you're not learning. And if you're not learning, you're not growing, basically. So be prepared to be uncomfortable rather than in your safe zone all the time. That way, you're stretching and growing and learning, right?
I've been doing this a long time. And I joked about I've been doing it longer than some of the engineers have been alive. And yet I learn something new almost every day. And I think that's the important thing, is to just keep learning.
Well, I learned something new today, Steve, and I really appreciate that. I had no idea you were you were at the sharp end of rockets. That's really cool. How do people get in touch with you if they want to? Is it through the Darcoid website? Would you like to be more available? How would you like that?
Yeah, they can contact me on the website. LinkedIn also, I have my profile for Steve Barton, and there's a LinkedIn. They can send me a message through that. Or worst case, they just call Darcoid and ask to get a hold of me.
Excellent. Well, audience members, I would thoroughly recommend you know Steve. I recommend that you have a relationship with him because better to have a relationship before you have a problem rather than scramble when you do have a problem. So Steve's your man. Thank you, Steve, for your time today. I've really enjoyed our time. Looking forward to meeting you when you're next in the area. And thanks to our audience. Looking forward to the next show. Thank you for spending time with us today. Thank you.
Thanks so much for the opportunity. I appreciate it.
Bye-bye.
Thanks for listening to the Makers of Our Future podcast. Behind every great product is a great seal. Learn more about how we can help at www.darcoid.com. That's DARCOID.com. The best seal, on time, zero defects, Darcoid.